One of the things that I'm really focused on right now are trying to understand sort of what's happening along our Great Lakes shorelines in terms of coastal erosion, things like habitat loss and infrastructure damage. And a lot of these things are happening because we're at high lake levels, and actually record high lake levels. And what that ends up doing is sort of putting the water's edge right in our backyards, right along where humans live.
In the United States, coastal erosion is responsible for roughly 500 million per year in coastal property loss, including damage to structures and loss of land. In addition to beach erosion, more than 80,000 acres of coastal wetlands are lost annually. That's the equivalent of 7 football fields disappearing every hour, or 168 fields every day.
And so when we get storms and we get winter ice and all these kinds of things that are very common along our Great Lakes shorelines, the high water kind of exacerbates those processes. And so that's what I'm really interested in, is trying to unravel all these different processes and sort of players and drivers and things like that into, how the coast is changing, document that, and then figure out ways of being able to predict.
Citizen scientists like Martha here will be flying drones along the coast of Michigan to generate images of coastal change. These images can be used to quantify erosion and accretion, as well as document other coastal impacts, such as coastal habitat loss or damage to coastal infrastructure. Once the citizen scientists collect the images, they send them to the research team at Michigan State University for processing. MSU researchers bring the images into computer programs that turn them into real data that can be used for decision making. The first step in the data processing, which we're showing here, is to stitch the drone images together. Once the images are stitched together, ground control points are placed in the image. These points are fixed positions that are visible in the image and were surveyed by the research team during the initial site visit. These ground control points are used to georeference the image, which allows the data to be compared to other surveys or data sets. Once these points are placed, the computer program will turn the imagery into data. While it looks like an image, what's depicted here are actually millions of data points. These data points are used to generate digital elevation models, or DEMs, of the coastal site. These DEMs show the topography of the site and can be compared to other DEMs to quantify erosion and accretion. Other important decision-making data can be gleaned from the DEMs as well, such as the location of the shoreline or the ordinary high water mark. In addition to the DEMs, seamless aerial photographs known as orthomosaics are also created from the drone imagery. These orthomosaics can be compared to historical imagery available for the site. They can also be used to document changes in the erosion hazard line, as well as human impacts or coastal vegetation changes. One of the most useful aspects of the citizen science data collection is the ability to compare data sets collected at different time periods. Coastal change can be documented and quantified by comparing images and DEMs collected at 2 different time steps. For example, this set of images and DEMs were collected in Manistee, Michigan before and after a fall storm. These DEMs can be differenced from each other to generate a map of exactly where and how much erosion and accretion occurred. The red areas are zones of erosion, and the blue areas are zones of accretion. These maps can be used to document the impacts of storms, fluctuating water levels, and even coastal management strategies such as shoreline hardening or beach nourishment efforts.